Hello everyone. So this is G. Ranjit Kumar, Assistant Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal. So in this session, I would like to explain the network connecting devices, and I would also want to show you that simulation of these network connecting devices. So network connecting devices are nothing but some physical devices which are used to connect different end devices. So this connection make all end devices to communicate to each other. For example, in this diagram, different end devices are there. So when these end devices want to communicate to each other, so these must be connected by using any of the network connecting devices. Many network connecting devices are there. So in this example, I showed you this is one network connecting devices, which is a switch. By using this switch, all these systems are connected to each other, and this switch is known as the one of the network connecting devices, so which makes one device to communicate with the another device. So without network connecting devices, the systems cannot communicate to each other. So some of the basic core devices includes this router, switch, and hub. So these are some of the uh, basic network connecting devices. So besides that, many network connecting devices are there, but these are the basic connecting devices. So now I would like to show you how this hub, switch, and routers are going to work, and I will also show you that simulation of these devices by using the packet tracer simulation tool. So first let us see the hub. The hub is the first basic network connecting devices. The hub is a hardware device. So this hub is going to work in the physical layer, which is the first layer in the OSI model. So OSI model contains 7 layers, out of which the first layer is a physical layer. So in the physical layer, this hub is going to work. Means hub is the one of the network connecting devices that comes under that works under physical layer. So it will connect multiple devices. But this hub is non generally we call this as the non-intelligent device, because whatever the message, so here this is the hub, and hub connected with the different devices. For example, so here this is the hub connected with 4 devices. This is hub network connected with 4 devices. So if this hub, assume that this is the source system and this is the destination system. So this is source system and this is destination system. So when this source system want to send a message to the destination, and this message, some message is generated by the system, that this comes to hub, and hub will simply broadcast this message to all systems which are connected to the hub. So this message will be sent to this system and this system and this system. That message is delivered to all systems which are connected to hub. But actually, this message is destined to only this destination system. But your hub cannot identify the what is the exact destination system that message should be delivered to. So that's why this hub is generally known as non-intelligent device. It cannot filter the data it receives, which means whatever the data reached at the hub, so reached at the hub will be sent to all systems which are connected to the hub except source system. So that is hub. So now I would like to show you this hub by using a packet tracer tool, so which is the simulation tool. So in order to use that packet tracer tool, I will show you how to download the packet tracer and how to use that. So in order to download this packet tracer simulation tool, so just open the browser. Just open the browser and type this Cisco Packet Tracer download for Windows 11, 10 or 11 or whatever it is. Just simply type Cisco Packet Tracer download. So then you get different links. So you open this link, any link. So let us open this first link. So when you open the first link, this netacad.com will be open. So networkacademy.com will be open. So in this different courses are available. So just you select the course exploring network with the Cisco packet tracer. So in this you register for this course. So it may ask you to register for the course by entering so your username and password. Otherwise you can register by using your Gmail account. Once your registration is completed with this course exploring networking with Cisco packet tracer, so then go to so that course content will be open. So getting started with the not this explore. So getting started with the Cisco packet tracer. So register for this course. So in this course you can find the curriculum. Under the curriculum, so download and use Cisco packet tracer. First module is there. So in this module here, install Cisco packet tracer is there. So you click this install Cisco packet tracer, then packet tracer tool will be downloaded. So once it is downloaded, just simply double click on that file. So automatically it will be installed. Just you go on pressing the next button. So automatically that will be installed. The installation is very simple. So once it's been installed properly, on the desktop you get this type of, so look at this. So this type of icon will be displayed on the desktop. So once it is properly installed. So just open this. Just open the Cisco packet tracer. This double click this Cisco packet tracer. So then you get this type of screen. You click this green color. So you get the message like this. You are successfully logged in into Cisco packet tracer. So when you will get once the Cisco packet tracer tool is downloaded and installed properly, so you get an icon on the desktop. So you double click that icon, then automatically it will be directed to the browser. So in the browser, so you once again you log in, and after successful login, so you get this type of message. So then below this screen here you can find Cisco packet tracer. Then just you click this Cisco packet tracer. Okay. So now this is your tool interface where I am going to simulate the network. This is Cisco packet tracer simulation tool. Now as part of the simulation, now I would like to show you how hub is going to work. Okay. So for that here left side, if you go to this left side, here below. So you can find this is just simply place the cursor on this device. Here it will show you the whether these are end devices or network devices. So this is first symbol represents network devices, and below this network devices here you can find a router, switch, and a hub. So you click this hub, and from here you select one hub. Select the first one and click here. So this is the hub. So which is the network connecting device. So which is going to connect the different end systems. End systems means our devices. Now after this is the first one, and after this, so here you can find, wait a minute, I am getting this symbol. So here look at this, this is network devices. So look at this, just you simply place this cursor on this symbol. So you can find end devices. You click this end devices. So under the end devices, here you can find PC. So you click this PC and click on this interface, this area, working area. Similarly, you take another PC and you click here. And similarly, you take another PC and click here. Right? So this is your hub. So this is your hub. So for this hub, all these systems will be connected. So in order to connect, here we have connection. You simply place this cursor here. You can find the connections. You click this connection and different connections are open. So this is your end device. This is your network connecting device. When two different types of devices are connected, so then we use this cable. We call this cable as a means a communication link, and the name of this one is the straight through cable, and this is crossover cable. I will tell you the difference between these two. When two different types of devices are connected, we use this straight through cable, and when similar type of devices are connected, we use this crossover cable. So but these are different cables. This is end device, this is network connecting device. So that's why we use this straight through cable. For example, if you are confused, so which is where we have to use the straight over cable, where we have to use the crossover cable. So then if you to avoid that confusion, if you are confused, so simply you select this first one and click on the end system and click on the network connecting device. Okay. So this will take, if you select this one, so then it will take automatically suitable communication link between two devices. Automatically it will take the suitable one. So this is the one way. Otherwise, if you are clear the difference between straight through and crossover, when we have to use the straight through, when we have to use the crossover, so directly you can select this straight through cable and connect these devices. So that's up to your interest. And similarly, again to connect this, you select this one and click on the end device and click on the hub. And similarly, third one also connected. So once these are connected here at either ends of the communication link, so you can find these green color symbols. Here green color and here green color. Okay. So once you find these green color symbols, that means connections are properly established between these two devices. So if this connection is not properly connected, so there you can find some orange color or red color symbol. So in this example, to either end of this communication link, so you get two green color symbols. That means this connection is properly established between end device and the hub. Now connection is over. So now to simulate how that message will be transferred between these devices, so three different devices are there. So first you have to set the IP address for all devices. So in order to set the IP address for all devices, so first you select this system. When you click on this PC0, so you can find this type of window will be open. You go to the desktop and here IP configuration and go to the IPv4. And here in the IPv4, you enter one type of IP address. So different types of IP addresses are there, class A, class B, class C, class D, like these different classes are there. Anyhow, that class IP address classification is different. But in this example, so just I would like to show you one IP address. You start with the 10 that comes under the class E address. So 10 dot 10 dot 10 dot 1. So IP address contains four parts. So each part separated by dot. So here I have used 10 dot 10 dot 10 dot 1. And after that below one field is there, just simply click that field. So automatically you get the subnet mask. Okay. So this is the class A address. That's why you are getting subnet mask as a, so 255.0.0.0. Okay. So what is the classes of IP addresses and subnet mask? That is the different case, a different concept. So, but here I don't want to cover that. So this is the way of setting the IP address for the PC1. So after that you close this. So similarly you set the IP address for the second system. Click the second system. Then automatically it will be open. So go to the desktop, IP configuration. So now here you set. So same 10 dot 10 dot 10 dot 2. So 10 dot 10 dot 10 dot 1 is over. So now this time for the second system I am setting 10 dot 10 dot 10 dot 2. So this is for the second system. So you click on the, sorry, I made a mistake here. Only four parts, I entered five parts. So 10 dot 10 dot 10 dot 2. So now this is address for the second system. So after that you close this. So now you go to the third system, desktop, IP configuration and enter 10 dot 10 dot 10 dot 3 and click on the next one, subnet mask. Automatically you get the subnet mask and close this. So now addresses, IP addresses have been set to three systems. Okay. So if you want to know which system has what is the IP address of this system and what is the IP address second one and third one. So here just as a note, so here you can find note. Okay. You click this symbol and you click here and you type 10 dot 10 dot, sorry, so 10 dot 10 dot 10 dot 1. So this is the IP address of first system. Okay. So similarly here you can type 10 dot 10 dot 10 dot 2 and this is 10 dot 10 dot 10 dot 3. Okay. So after that just you escape them. So these are the addresses of three different systems. Just in order to, so no, you can make a note just beside that system. So if you remember that IP address, no need to write these notes. So that's up to you. So now in order to simulate, you on top of this window, here you can find PDU, this symbol. PDU means protocol data unit, PDU. So message symbol is there. Just you click that message symbol and select any system as a source system. I have selected this system, first one as a source system. So that's why click this first system and click on the destination. Let us take this is the destination, click on the destination. Any system you can take as a source and destination. So once these two systems are taken, so below this window, the below right corner, you can find a simulation. You click this simulation. So here you can find play button. So now you play this. So look at that simulation. Goes to hub. Now message passed to all systems. Actually, from here we are sending a message to this system. But whatever the message sent to the hub, that is sent to two systems. Here you can find red color symbol and here it will show you some green color symbol because this is the destination ready to take the message, but this is not the destination. Okay. So here you can find even though there is only one destination, but message is sent to all systems which are connected because this hub nature is non-intelligent device. So that's why it will transfer the data to all systems. So that is the problem with so this hub. Okay. So in this way you can simulate hub using the packet tracer. Okay. So now again you play, just I stopped in the middle, again you click on this play button. So now message in return going from acknowledgement going from the destination to sender. So now also you can find, so here green color tick mark is there because this is the source system, and here red color into mark is there, cross mark, because this is not the actual source. This is not the actual source. This is not the actual destination. That's why there you can find the symbol in the red color cross mark. Okay. So in this way you can simulate the network using a hub. So hub is one connecting device. Okay. So, so after that you can stop here. So this is about hub, how this hub is going to work. So we call this hub as a non-intelligent device because it will not store the destination address. Whatever the data sent, that will be broadcasted to all systems which are connected to the hub. So now coming to the switch is the next system, next network connecting devices. So this is also almost similar to the hub, but there is a minor difference. So look at this. The switch is a hardware device connect to the multiple devices to form a local area network. This point is similar to the hub, but it operates at the layer 2. Earlier hub at the layer 1, which is physical layer. The switch operates at layer 2, that is the data link layer. So this is part of the OSI model. And this is intelligently send the data. So this switch is known as intelligent device because so it learns the physical addresses of all devices which are connected to the switch. Right? So whatever the message is sent from the source, so that will be delivered to exactly the destination system, but not to all systems. So in the hub case, the whatever the source send the message, that will be sent to all other systems which are connected to the hub, that is known as the broadcasting. But here switch will not send the message like that. So let us see, for example, So here this is one switch. This is a example for the switch device. And using the switch here, four systems are connected here. This is first system, second system. Let us take third system and fourth system. Four systems are connected. For example, assume that the first system is sending a message to the third system. So then this message sent from the first system that will go to the switch, and switch will learn the address of the destination system. So destination system is the third one. That's why this message will be delivered to only third system, but not to all other systems. So that's why, so this switch is known as the intelligent device, because it learns the MAC address which are connected, physical address or MAC address which are connected to this system. But in case of the hub, the message is delivered to all systems which are connected to the hub. So but here the switch that will send message to only the destination system which is connected to that switch. Okay, so this is the difference between hub and switch. So now let us see the simulation of this switch, how it is going to be simulated. So almost that same simulation process is the same as far as this hub is concerned. Hub and switch are same, but only that device will be changed. I will show you that. Now again let us go to the packet tracer. So if you just you stop this, if you want to delete this, simply select this earlier. You can also save this for the future reference if you want. Otherwise, if you want to delete, just you select that area and simply delete this. So now this earlier project has been closed. So now the same process, let us see. So go to the end device, below left corner of, so below this screen left corner you can find, just you place the cursor here. So this is end device, network device. Now below this you can find switch here. Just place the cursor on the symbol so that description will be displayed, name of the symbol will be displayed. So now from here you select the first one, anyone you can select. So this is your switch, right? So now you select the second one here, end devices. Now from the end devices you select this PC and click here, and you select this, click here. So three systems I have taken and clicked on this. So now you connect, the connection procedure is also same. Now go to these connections and select this symbol if you don't know. So which symbol has to be used, whether crossover or straight through cable. Select this orange color symbol, click on the PC one, first PC and switch. So in case of the hub, immediately you got green color symbols here at either end of the connection. But in case of the switch, it may take some time to turn those red color symbols into the green. So because it learns the IP address of, MAC address of these systems. Because this is an intelligent device, all the systems which are connected, their physical addresses will be stored in the switch. That's why it takes some time. And similarly, you connect the remaining systems also. Automatically, that will be converted into the green color gradually. So just wait for time. And in this meantime, you set the IP addresses for all these systems. Similarly, the same process, how you assigned IP address in case of the hub, same process. So you click this first system, go to the desktop and IP address, and here you write 10.10.1. IP address classes are there. If you know the different classes of the IP addresses, you can set your own class address. So but here for every example I am using class A address. So let us take 10 dot, same addresses I am using 10.10.10.1 and click on the next one. So automatically you get, so close this. Okay, so IP address has been set. Next, click on the second system, second PC, and desktop and IP address. So now this is 10.10.10.2, and click on the next one and then close this. Now click on the third system here, PC5, desktop, IP address. This is 10.10.10.3. So click on the next field and close this, right? So now you delete, then message symbol will be disappear. Now look at this, at either ends of the cable you got green color symbols. Earlier it was red and that is converted into green color because all IP addresses have been properly assigned, and you are getting green color at either ends of the cable. That means this cable has been properly connected, two devices have been properly connected. So now for the simulation, you go on top of this screen here, you can find a simple PDU. Click this PDU and click the source system, any system. I am taking this system as a source system. You click on the source system and let us take this is the destination. So now you click on the destination. So then below you can find here a right corner of the screen simulation. Click the simulation and here you get the play button. Otherwise this left side also you can find the play button here. Click this play button. So look at the simulation. So here you can find once this message is sent and acknowledgement received, in the second time that message is delivered to only this system because I have selected this system as the destination system. But in the hub case, that message is delivered to all systems which are connected to the hub. Okay. So this is a switch. The switch will deliver the data to only one particular device, so which is selected as a destination. Okay. So this is the difference between switch and hub. The the hub will deliver whatever the message sent from this system will be delivered to all other systems because it will not store any physical address. But coming to the switch, it will store the physical address of devices connected to this, and based on the physical address it will send the message to only one particular destination. So this type of message transfer is called as the unicast, one source, one destination. But here in the hub, one source, but message delivered to all other systems. So this is known as the broadcast. Okay. So this is the difference between source and the, I mean, hub and a router. So this is, I showed you two devices practically by using this um, Cisco Packet Tracer tool. So hope you understood this what I simulated, that simulation of hub and that switch, right? So with this, just I would like to conclude this session, the demonstration of that simulation of hub and switch, right? So thank you very, very much for your patience on listening to my session.